Today's video is going to be a walkthrough of Module 3, Lesson 5 for Grade 7. Today's lesson is factoring expressions. Start with this first problem here. It says compare the expressions 3 times the difference of 5x and 4. So 3 times 5x minus 4 and 15x minus 12. Identify similarities and differences between them. If we're looking at this expression right here, you might notice we have a subtraction expression in parentheses multiplied by something on the outside. We have learned recently that you can use the distributive property to write an equivalent expression. So if we multiply 3 times 5x, that gives 15x. And if we multiply 3 times the negative 4, that gives us the minus 12. So these two expressions end up being the same. They are just written differently. When we use the distributive property, and we're using the tables, we're multiplying 3 times 5x, so 15x, and 3 times negative 4, which is negative 12. So just like we did previously, we have that expression, not 4, negative 12, which is just like what we did in that number 1 problem. We can kind of work backwards to do the opposite. Okay? We distribute when there's a number outside or something outside of those parentheses. But in this case, we're trying to figure out what we started with to get here. Well, this blank line here out front of the boxes represents what can be pulled out. What factor do 15x and negative 12 share in common? What is the greatest common factor these two numbers have? Okay. Well, if we think about the factors of 15, okay, we have 1, 3, 5, and 15. For negative 12, there are quite a few. There's negative 1 and 12, 1 and negative 12. Let's just go through. We have 2 and 6, 3 and 4. 3 appears for both of these. So we can say that a factor of 3 is shared between the two numbers. Once you decide what the factor is that happens in both numbers, you're going to divide each of these numbers inside the boxes by that factor that was pulled out. So if I take 15x divided by 3, I get a 5x. Negative 12 divided by 3, negative 4. Okay. With this, that would represent the expression 3 times 5x minus 4 or plus negative 4. Okay. Because if you think about these two tables right here, what we got when we multiplied is inside the boxes. Okay. When they give us the blanks outside of the boxes, we're trying to figure out what problem it is we started with. What was the expression we started with to get the 15x and negative 12? This is called factoring an expression. Okay. We're trying to find a factor of both numbers that we can pull out, divide both of those numbers by that to see what we would start with from the expression. Okay. So when we use this, we get the equivalent expression. We multiplied that out and we had the 15x minus 12. Okay. Because when we multiply 3 times 5x, we get the 15x. 3 times the minus 4 gives us minus 12. Okay. We're going to use some of these expressions here to do some factoring. We're going to start with this problem right here. Okay. So if we're looking through, first off, we need to kind of talk about what the factors of 27 and 81 would be. Okay. What I do is I go through and I just say, oh, 1 times 27 gives 27. Well, 2 times nothing. 2 isn't a factor of 27. I have 3. Well, 3 times 9 equals 27. 4 times nothing. Okay, so 4 isn't a factor. 5 is not a factor. 6 is not. 7 is not. 8 is not. Well, now we're back to 9. So I've hit all of the factors. These are all the factors of 27. If I do 81, do the same thing. 1 and 81. I know 2 is not because we don't have an even number. So if I try 3, well, 3 goes in twice. That leaves 2 left over, which is 21. And 3 goes into 21 7 times. So I have 3 and 27. 4 does not go in. 5 does not go in. 6 does not. 7 does not. 8 does not. And then we have 9 times 9. Well, since we have the 9 times 9, we've kind of back to where we're kind of in the middle. So we have all of these factors of 81. Well, they share this 27 in common. They also share 9s and 3s. So we could factor out any of those 3 numbers. So if you don't factor out the greatest common factor, that's okay. There's lots of different options we have available. So let's look at 27 now. If we said 27, 27x divided by 27 gives us 1x, or x. Because remember, there's a coefficient of 1 here if there is no coefficient showing. And then negative 81 divided by 27, you get that negative 3. So when we have our expression 27x minus 81, that is going to factor a 27 out and leave us left over with x minus 3 or x plus negative 3. And if you use the distributive property and multiply out, you'll end up with this expression right here. Okay. Question number 5 is doing the same thing, except for now we have 3 numbers. Well, my factors of 15, okay, would be 1 and 15. 2 is not an option. 3 and 5. And 4 is not a factor of 15. Okay, so 20 would be 1 and 20. This is an even number, so I would have 2, 2 and 10. 3 is not a factor of 20. 4 is a factor, and 4 times 5 is 20. We have 1 and 50, 2 and 25. 3 is not a factor of 50. Sorry, I was having a little trouble here with the camera, trying to keep it stable. 3 is not. 4, okay, well 4 is even, but it doesn't go in evenly into 50. 5 does go in, which gives 10. 5 times 10 is 50. 6 is not a factor. 7 is not a factor. Either it's 8 or 9. And then we're back to a 10. Okay, so what do they share? What do all of these share in common? Well, they all share 1 in common, but that's not the biggest one. Because the next factor they all share in common is a 5. So we could pull a 5 out. We could factor a 5 out of each of these. And now I'm going to divide each of these numbers by 5. Well, 15x divided by 5, well, 15 divided by 5 is 3, so 3x. Negative 20y divided by 5 is negative 4y. And 50 divided by 5 is 10. So for this expression, we would factor out the 5, and we would multiply that by 3x plus negative 4y plus 10. Okay, question number 6. When we see fractions, we want to try to make sure that we don't have any fractions up in these blanks. Okay. So in this case, I have fractions in both the x and y. Well, both x and y have coefficients of 1/2. So if I said I'm going to pull 1/2 out of here, because that's the fraction that shows, okay, well, 1/2 x divided by 1/2, well, 1/2 divided by half is 1, and 1x is just x. Same thing here with the y. 1/2 y divided by 1/2, well, 1/2 divided by 1/2 is just 1, and 1y equals y. Now I have negative 1 divided by 1/2. Well, negative 1 divided by 1/2. Okay. Well, when we divide with fractions, we need to make sure that we have all fractions, so turn our whole number into an improper fraction. And then we multiply by the reciprocal. So 1 times 2 is 2. 1 times 1 is 1. A negative times a positive is a negative. And negative 2 over 1 is simply just negative 2. So we have 1/2 out front as our multiplier, and our terms inside the parentheses, we have x plus y plus negative 2. Number 7 is a little different, because not only can we look at our factors of our numbers, but notice that each of the boxes has an x in the term. Okay, so we can pull an x out as well, because x is part of that factor that they share in common. If they share variables in common, those can be pulled out as factors as well. Okay, so if I think about 7, my factors of 7, well, that's 1 times 7, because 7 is a prime number. Well, 21 is 1 and 21. It's not 2, 3, and 7. 4 doesn't go in, 5 doesn't go in, 6 doesn't go in, and we're back at 7. So if we look here, notice 7 is that greatest common factor. So I'm going to pull a 7x out of these two terms, dividing both by 7x. Well, 7xy divided by 7x, well, 7 divided by 7 is 1. X divided by x is 1. So I have 1 times y, which is simply just 1y or y. If I divide negative 21 by 7x, the x's will divide out to be 1. And negative 21 divided by 7 is negative 3. Negative 3 times 1 is just negative 3. You can kind of think of it as when you're dividing variables by themselves, if it's just the one, if there's just one as the exponent for each of the variables, it's kind of like they cancel out and just disappear. Technically it turns into 1 over 1, and if you multiply by 1, that doesn't change anything. So we just consider that to cancel out, And that would leave us with a multiplier of 7x, and the expression inside would be y plus negative 3. Okay. So when you're factoring, you can use the table to help you out. Okay, make your blanks, divide them both. But if you don't have a table, okay, so like questions 8 and 9 here, okay, you can still think of it as a table. Okay. For instance, well, what multiplies to give me 14? Well, I know 1 and 14, so 1 times 14, 2 times 7, and that's all of our factors of 14. For 42, have 1 and 42, 2 times 21, I have 3 times 14, 4 is not a factor, 5 is not a factor, but 6 times 7 gives me 42 as well. So if I'm looking, I notice that I have 14 as my greatest common factor. Also looking at this expression, I notice that each term has an x. So I'm going to divide both of these by 14x. Well, 14xy divided by 14x, and I'll show you guys what that looks like here. So 14xy divided by 14x. Well, 14 divided by 14 is just 1. Okay. So 1 over 1, okay, times x divided by x is just 1 times y. Well, 1 times 1 times y is just y. 1 times 1 is just 1. And anything divided by 1 is just itself. So I would be left with the y. I pull the x out, so there's no x left in here anywhere in this 42. And 14 times 3, so minus 3 or plus negative 3 is going to be my expression in the parentheses. Now, could you have pulled 7 out or 2 out? Yes, absolutely. It would look a little different, okay, but that would be okay as well. Okay. Question number 9, we see decimals, but we're not going to do anything. Again, we would like to not have any decimals inside the parentheses. So we got to think, what could we divide all of these by? Well, always try dividing by the smallest decimal first. In this case, the 2.4. So if I pull 2.4 out of everything, well, 2.4x divided by 2.4 is just x. 1x, because 2.4 divided by 2.4 is just 1. So that leaves us x minus, well, 4.8 divided by 2.4 is 2. And it's 4.8y, so that's 2y. And then 24 divided by 2.4 is 10. Notice I have no decimals left inside the parentheses. Okay, your multiplier can be a fraction or a decimal, but we prefer to not have any of those in the expression that we're multiplying into if possible.